Hello, good morning everyone. So in the first part of the video of this chapter, periodic classification of elements, we had seen up to the merits of Mendeleev's classification of elements. Today we are going to see the anomalies of Mendeleev's classification of elements. That means what were the demerits, what were the defects. So there are mainly three defects. One of the defect was about the position of the isotopes. This Mendeleev, he could not make it clear that where could the isotopes be placed. See, first understand, you have already studied in class 9. Let me revise it. What are isotopes? Isotopes are the atoms of the same element having same atomic number but different mass number. So it was questioned by the contemporary scientists that certain elements like chlorine, they have got two isotopes 35, 37, carbon 3 isotopes, carbon 12, carbon 13, carbon 14, hydrogen 3 isotopes, protium, deuterium and tritium. Then where should these isotopes be placed? Because he had arranged the elements in increasing order of the atomic mass, and isotopes have got different atomic masses. So where should they be placed? It was not answered by Mendeleev. He could not answer this. That means this was one of the defects of Mendeleev's classification of elements, that the position of the isotopes was not clear. Next it is, he had second defect, we can say, second anomaly was that about the wrong placement of the some of the elements. For example, cobalt and nickel. Cobalt, it has got its atomic mass at 58.9 and nickel as 58.7. So cobalt should be placed later on and nickel should be placed first. When it was questioned by the contemporary scientist from Mendeleev about the explanation, he could not explain why he had placed cobalt first and nickel later on, although cobalt has got more atomic mass than nickel. And the third demerit was that about the position of the hydrogen. The position of the hydrogen was placed with the metals, although it is not a metal. It was placed by him in the first group along with the sodium and other elements. Then he could not give the explanation. That means he could not mention the proper reason why hydrogen was placed in that table, in that group along with the other elements which did not have the property or that of a non-metal, because hydrogen is not a metal, it is a non-metal. Now we come to next part of the chapter, that is the present basis for the classification of elements. So in 1913, Henry Moseley, he came forward with his new idea about the arrangement of the elements. He told that let us forget all what we have studied till now, what we have done till now. Let us arrange the elements in a different way, in increasing order of the atomic number instead of atomic mass. He told that we will arrange the elements in increasing order of the atomic number, not in atomic mass. But when he arranged these elements in increasing order of the atomic number, it became similar to what Mendeleev had done. Mendeleev was lucky enough that when the arrangement was done according to the atomic number, increasing order of the atomic number, then his group his arrangement matched, because in the earlier stage it did not differ much. But when the later elements that was not found by Mendeleev, that was not arranged by Mendeleev, that were arranged in a different way, but it was also done in according to the atomic number. So what is the present basis of the classification of elements of the modern periodic table? The basis of the classification of the modern periodic table is the atomic number, not the atomic mass. So we have got another law that we call the modern law. Modern law. What is that modern periodic law? The modern periodic law says that the properties of the elements are the periodic functions of their atomic number. Till earlier we had seen about that. They have been telling to us, Domanier, Newland, and then Mendeleev all have told us that the periodic functions of the elements are the atomic mass. That means atomic mass is, on the atomic mass the properties are dependent. But no, when Henry Moseley came forward, he totally changed the concept, and then he told the properties of the elements are the periodic functions of their atomic number and not the atomic mass. So what changes took place by his arrangement? When he gave this arrangement in this atomic number 1, then what happened? Whatever anomalies were there, that were in the Mendeleev's classification, 2 of them were solved. What was that? About the isotope. About the isotope it was there, no? About the isotopes. It was told about the isotopes. So when he did, in increasing order of the atomic number, Henry Moseley, then what we say? That atomic number will be same in case of isotopes. So do isotopes need to be placed in other place? Do we need a new place? No, we don't need. So the problem of arrangement of the isotopes of the elements was solved when it was changed from atomic mass to atomic number. Second anomaly that was about the cobalt and nickel one. Cobalt we had seen 58.9 U was its atomic mass and 58.7 was that of nickel. But Mendeleev had placed cobalt first and nickel later on. But when we come to the atomic number, then we see that this cobalt one, cobalt has got atomic number of 27. Cobalt has got atomic number 27. And nickel has got 28. Although this cobalt had got 58.9 U and 58.7 U atomic mass. So Mendeleev had done by this way. Although it was more, but he had placed earlier and this one he had placed later on. But when it came to the atomic number, then it became by itself correct. So thus in this way we can say what was the anomaly in the case of Mendeleev classification was solved when it was done by the atomic number. So these 2 anomalies were solved. But third anomaly, that is the place position of the hydrogen, it is still an anomaly. In the modern periodic table also it has not been solved, and still our scientists are working on to know the reason or to give a new position to the hydrogen, a proper position if it could be, or what could be the correct explanation for the position of the hydrogen. The studies are still going on. Now we will see the explanation of the modern periodic law. So what we saw in the modern periodic law, we had seen that the properties of the elements are periodic functions of their atomic number. That means in the modern periodic table, as per the modern periodic law, the elements are arranged in increasing order of their atomic number. And it is seen that when it is arranged in increasing order of their atomic number, then the properties are repeating. They are repeating as per the electronic configuration. And therefore in the modern periodic table we are seeing that the have been arranged first in the first one 2 elements, then again 8 and 8, and then 18, 18, 32, 32, like that. In this way the arrangement is being done. So when we come to the explanation, then here it is given that when elements are arranged according to the increasing atomic number, the elements having the same number of valence electron occur at regular interval. That means the element having the same valence electron, they occur at regular interval. For example, when we will see about the hydrogen, helium, then we come to lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and then neon. Then here we have got sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. So when we are seeing their atomic number, let us write the atomic number also. I am writing the atomic number. 1, 2, here it is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, this is 10. This one is 11, this is 12, this is 13, this is 14, 15, 16, 17, 18. So let us do the electronic configuration. What we are doing? 2, 1. In class 9 we have studied about the electronic configuration, how to do the electronic configuration. So here we have 2, 2, here 2, 3, 2, 4. Here this one is 2, 5, 2, 6, 2, 7, 2, 8. And in this one when we do 2, 8, 1, 2, 8, 2, 2, 8, 3, 13. Here 14, 2, 8, 4, 15, 2, 8, 5, 2, 8, 6, 2, 8, 7, and 2, 8, 8. So what we are seeing? See the valence electron? 1, 1, 1. So they are coming here. That is what is told in this modern periodic law. That the properties are repeating as per their valence electron. See here 2, 2, 3, 3, 4, 4. More in this way you will see the whole periodic table, and then this modern law is being followed here. Next we have modern periodic table. So the credit for the arrangement of the elements in the modern periodic table goes to Niels Bohr. Niels Bohr is the scientist. In class 9 you have studied Niels Bohr. What he had done? He had given the model of the atom, Niels model of an atom. He had given so many postulates regarding how the atoms are there. What were the arrangement, how the elements are, how the atoms are arranged, how the electrons are arranged, how the protons, about the K element shell, and many more things he had told that you have studied in class 9. And in this same person, Niels Bohr, he is the one who is being given the credit. The credit goes to him only for the arrangement of the modern periodic table. Although he has not done alone, he has done along with Henry Moseley. Now we will see the modern periodic table. This modern periodic table, it is also known as the long form of the periodic table. And in this modern periodic table, what we will see in the modern periodic table, this is a part of the modern periodic table, we can say that there are vertical columns are there and then horizontal rows are there. This way, this horizontal, these are the horizontals. This one, in these all we call them as the periods. This period number 1 we can say. Then here is the period number 2. This is period number 3. Period then here more will be there. Period number 4. Then period number 5. Then it is period number 6, and there are period number 7. So you will see there are 7 periods and there are 80 groups in the modern periodic table. Here this is the first one, group number, this is group number 1, then you have got group number 2, then here we have got group number 3, and like that we have, and the last one we have got group number 18, and this halogen one, it is group number 17, and so on. So in your book you can refer to the chart, the periodic table given there, where the elements are arranged in such a way that there are 18 period groups and 17 periods are there. And in this periodic table, what we will see, that there are in the period number 1 there are 2 elements, and this period is known as very short period, very short. Why? Because only 2 elements are there. Period number 2 and 3, they are known as short periods. There are only 8 elements arranged in them. Period number 4 and 5, we call them as the long period. And last 4 and 5 and 6 and 7, we can call them as the incomplete one. Incomplete one. See, in your book they have also given in this way that the first period is very short, second one is short, third one is also short, and the fourth one they have given long, and fifth one they have given also long, and sixth and seventh they have called them as very long. So that way is also correct. But when you refer to your periodic table, there we will see that it is incomplete. 6 and 7 they are incomplete. So we can call them as incomplete one, or as it is, we can understand it that way, that only 2 elements are there, so very short. 8 elements are there, so they are known as 2 and 3 are called short. And then these 4 and 5 they are called long, and 6 and 7 periods they are called very long periods. Next we have about the lanthanides and the actinides. In this period number 6, when you refer to your book, period number 6, you will see here what is there in between. You will see after 56, from 57 to 71, it is not given. It is given at the bottom, and they are known as lanthanides. And why this is known as a lanthanide series? Because the first element of this series is lanthanide. Now in period number 7, you see from 89 to 103 it is not placed there. They have been separately placed here. They are known as actinide series. Why they are known as actinide series? Because the first element is the actinide. So you need not learn the whole periodic table. You need to learn only 1 to 20. In class 10 you need to learn elements name from 1 to 20. Their atomic number, their mass number, their electronic configuration, their name, their symbol. And after 21 you will learn in our class 11 and 12. And you can learn some important one more you want to study. That means you, for a better knowledge, you can keep these noble gases one. You must learn the helium, neon, argon, krypton, xenon and radon. These 6 one you can learn. If you want, you can learn about the fluorine one also. This one halogen group, that is fluorine, chlorine, bromine, iodine and astatine. These many you can learn them there. Then few more are there. For example, cobalt is there, nickel is there, iron is there, which are not coming under up to 20. So they are later on. So you can learn their name also, their symbol also, their atomic number, their mass number. It will help you. Now in the modern periodic table, one more thing you will see, that here these elements here, that is shown by different color, they are the metalloids. Okay, that in the beginning only of the chapter only I have told that there are 8 metalloids and they are given there. You can learn the name of the metalloids also. Next is about the position of hydrogen, that we have already discussed earlier. that the position of hydrogen is not proper. In the modern periodic table also, the position of hydrogen is not perfect. Still, confusion is there. Questions are there that this hydrogen has got one valency. Then this halogens also they have got one valency. They should be placed here. Why are they not placed here? Because these are non-metal and hydrogen also non-metal. It should be placed here. But see, since metals donate electron, in the same way, hydrogen also donate electron. So they have been placed in this group. Because these they accept electron, and this hydrogen does not accept electron. So there may be many more questions that may be coming to your mind about the hydrogen. So in future, when it is known to us, when the scientists they find out and they tell us, we will be able to know about them. Now we come to elements having one valence electron. Element having valence electron 1, they are placed in group number 1. Elements having valence electron 2, they are placed in group number 2. And elements those having valence electron 3, they are placed in group number 13, 4 group number 14, 5 group number 15, 6 group number 16, 7 group number 17, and those elements that have got 8 valence electron, they have been placed in group number 18. Next part. Next part we will see another day now.